data wrangling section that we're going through, i.e. The means to change the way that your tables look and to move things around so that things are a little bit more organized, is actually probably one of the more helpful parts of the class, because I think that you'll find that when you're working on your own analysis projects, wherever that may be, one of the big things you'll be doing is spending time actually going through, actually kind of importing your data or clearing things up and making it look a little bit more, make it useful. Otherwise, when you first get data, it just comes to you as kind of a big block of numbers. But when you start kind of looking at these numbers, you think to yourself, well, I would like to do this kind of plot, or I'd like to run this kind of model. I'd like to do this, this, and this. But the thing is, though, that in order for you to do those things, you have to start getting the data in some kind of form you can do. And so I believe that we are right here at this section, chapter 8 and 11. And so I'll just go through. I think we hit these slides before. I can find where we left off. I think we left off. Well, I'll just start here, I guess, and then I'll kind of like skip around as time dictates. But really, what we're talking about now is the notion of tidy data. Now, in tidy data, let's start here. Tidy data is characterized in the following way: that each column each variable has its own column. In other words, you're not mixing things together. So in this data set, you see that countries all together, all the countries, we have Afghanistan, Brazil, China, they're all countries and they're all in the same column. That makes it easy if you're running some kind of analysis where you need to go after country names, and that go after you know where to find them in the country column. Furthermore, we have the year. The year information is also in the same column. We have 1999 and 2000. I'm not too in love with the idea that we have two different kinds of years. It seems like we only have 1999 or 2000 in this data set. So I'm not too, excited about the idea that we have two different years in our column, and maybe we should have two different columns, one for 1999 and another one for 2000, rather than having a year column. But maybe that's okay. Then we have cases. That's information about. I'm not really sure what these cases are. Maybe these are some kind of sickness, or maybe it's not the pandemic. It's older data than that, but it's cases of something. And then you have the population. The population is also in these columns. Now, if you look at how to read these columns, you'll see that Afghanistan, 1999, cases 745, and then population. You can see that each row actually does have some information, but you have to look at Afghanistan 1999 and Afghanistan 2000 if you'd like to compare or see how the cases have arisen in this case from one year to the next. Anyway, so what I'm talking about though is that if you wanted to work, if your analysis suggested that your data had to be in this form, then you could use some of the functions that we're talking about today to actually put your data in this form so that you can work with your data. But each column though, over here, each variable must have its own column. Each observation must have its own row. In other words, you can see that Afghanistan and 1999, 745, and then we have, what do we got here? 19,987,071. That's our population. But that whole kind of relationship between those numbers is all in its own row. And then the final thing is that does each value have its own cell? One thing I find very annoying about downloading data online is that sometimes the data is all packed into one giant cell. How are you supposed to go through with ggplot down all those columns and actually get that information out of each cell? I mean, it's virtually impossible. And so you have to do something you have to move things around. So this is like what I'm talking about when things are not tidy. For instance, here we have the other data was tidy, like neat and tidy. But here it's not tidy. So we have Afghanistan 1999 and Afghanistan 1999. We have two Afghanistan 1999s. But we have this in our column type, it either says cases or population. Now, cases or population is not data. That's a descriptive of what the count is all about. So it's like cases or population is informing us how to read the next column called count. So cases is 745. As you can see, if I go back here, excuse me, cases is 745 for 1999. You can see that it makes more sense having cases in this column here than it does here, because cases, then I have to read the row cases, and then I go to the next block over and see the count. And so that's just kind of, I mean, while it works and we understand the convention, we see how we understand how you can read the information, and it's still clear to us, it doesn't make it easy, because if I wanted to run count, if I wanted to do some plotting with count, imagine how I would do that. Before, I just go to ggplot, and I just say ggplot, give me the whole, the whole column of count, and show me the numbers. But in this case, I cannot do that because I need to somehow inform ggplot that some of those numbers are cases and other values population. And so I don't want to mix those two things together, like, mixing the wrong types of data into the result that you get will just be confusing. So that's not tidy. And so what we're talking about though is like running all these different kinds of or these built-in lines of code to allow us to really undo some of these problems. So for instance, here, one thing I'd like to show you, I think let's go to my, I will go to R now, maybe it's time. Okay, so I'm loading up R. Hopefully this will come up. See this? Yes, you can. Okay, so I'm going to go and open up you see this? You can. I'm going to open up my R script, and I'm going to load my library, TidyVerse. You always want to do that. Run it, and then you'll see that when you run TidyVerse, by the way, you seem to get a lot of stuff that comes out. This is just saying that TidyVerse has this. TidyVerse is a mixture of other libraries. It's a whole bunch of things put together. So in TidyVerse, for instance, you have ggplot, you have this tibble, you have this tidier, you have reader, you have forcat, springer, a bunch of stuff in here. You don't have everything, but you do have a bunch of things in here that are quite useful. And so when you run this library TidyVerse, I received a question recently about how am I supposed to make sense of all this stuff here? Well, these are just the libraries. If you know that your code, for instance, relies on ggplot 3.3.0 and above, then you're good to go when you run TidyVerse. And so that's really all this information is. Other times, for instance, when you run a library, I'll just run another one here, tibble. You get nothing. There's no output. Let's assume that you know what the library is. Anyway, let me just go ahead and put the date in here. The date are the 20 October. Is that true? Today's date is 2020. Oh my gosh, the planets must be in alignment or something, you guys. Maybe they're not. Who knows? I think that's really kind of interesting. 2020. I'm now saving my file, so I know you can't see what I'm doing, but I am saving it. I'm just putting a place. I'm just trying to find a place where I can store it so that I don't erase it by mistake, because often I do. Okay, so let me just go ahead. Oops. I'll put this in week 7. And I'll call this 20 October 2020. Hopefully you have it there, the name. Okay, good. Now I'm going to run this here, and then if I go back to my slides, what are we doing? So we're looking at this new command here called. We have these built-in data or these tables of data called table 1, 2, 3, 4, 4a. I think 4. Is it 4? Was it 4a and then 4b? But these are all tables. Like for instance, this table here is table 2. This is built-in data. It's built-in data that's been purposefully kind of mangled in a way that makes it complicated. So let's see what that looks like. And so if I go back to R, and I look at this, I type in, for instance, table 2, and I can run that. Running, whatever. So table 2 will show me this data where it's really kind of, it's not very tidy. You can see how the cases and population are both in here. This is the cases. It's just hard to work with it. You can always view this if you like by typing view table 2 and then running that, and you can see that this spreadsheet up here. It seems like we have just 12 lines, but you get the point that it's not easy to work with data. Next, I'm going to go back to my slides, if I may. Oops, lost them. and let's see what they have to do. So, okay, so we're going to run this piece of code here, which is going to be called, okay, we can run this code here. There's this counting here. So you can actually use count to kind of get an idea. Well, I don't know why this is right. Um, you can use count to get a kind of an idea about how many different types of cases there are. This is just a piece of information actually before we start wrangling things. If I go ahead and run that, you'll see what happens when I go ahead and put this in here. And so I'm looking at table 1, by the way. Before I run that, let me just show you what table 1 looks like. Table 1 is like this, where I have cases and population. It appears to me to be quite tidy. And so if I wanted to find out, for instance, how many different types of cases there were, um, I could run this, and what this does is it kind of groups together my, I hope you can see this, but it groups together the different numbers of cases that I do here. I would do this, I would need to know, like, for instance, how many cases I have if I'm considering breaking up the cases into 2 different tables so that I can actually, make 2 different plots. You might need to know that if you're making a different plot for cases in 1999 and cases for 2000. So you run this thing here, count, and what this thing does is it says, okay, go to the year. So this is that column right here. Go to the year column. And then what you're doing is you're looking at the weight, and the weight here says, look at the year, but then also keep your eye on organize your data or aggregate your data according to the information that you see next door. In other words, go to the year column and organize the data from 1999 to 2000, but then again, organize the data or count the data in terms of the different cases. So the cases for 1999 would be this case here, this case here, this case here. So we're keeping those cases together with the year. And then for the year 2000, we're keeping those cases together with that. So you kind of get this interesting code that allows you now to add up the cases by year. Now you might need this if you're considering actually breaking up your code or breaking up your data table in some way so that you can get some more in-depth information. Let me go ahead and go back here. Oops. Anyway, but this is how the numbers are broken down. You can add these numbers together, and you get this. And this number here, 250,000, is where this number came. So really, just adding up the case. You might try that for some things. Here's another thing you can do. If you're looking at the table 1, you can still kind of count. Let's see. You can count the table 1 data according in the country, taking the information from country, breaking it up into 2 different groups, and you're keeping track of the different populations from those different groups here and counting those. And so this is another piece of code you can run that would help you to kind of figure out how you can break the data apart. Remember, all this stuff that we're talking about now is about taking a table where things have been kind of mangled together in some unusual way and then pulling things apart. We could do some plotting here. Maybe I'll save some time and not actually put this plot up there, but I think I have the plot right here. One thing I'd like to talk about, though, is when you run this code, you should get this plot here. Afghanistan, Brazil, and China. Now, this is actually quite an interesting idea. This is, in fact, this is where our practical is coming from today. It came from this particular plot, and I thought there's got to be a lesson in all of this. But what I'm looking at, though, is that here we have a plot where we have, look at this, 1999.00. That's the way it plots the year. All the way to 2000. Now, it's saying that the I guess the China line, the blue line, if you can see where but the top line here, it's basically a flat line. It's saying that China is not changed. The values for China isn't changed. However, the China or the numbers for Brazil are changing. Look like they're going from below 50,000 to almost just under 100,000. So it seems like that's a big change. Now these numbers are changing, and let me see that and let's see that we have 1999 to 2000 for Afghanistan. It's saying that the numbers are down, and so the numbers are not changing. But what the problem that I have with this plot is that if you look at the year 1999.5, like halfway through, I guess that's what, June or July in 1999, you have information to suggest that the number In fact, I'm looking at Brazil right now. I have information to suggest that the number is probably about, I don't know, 60,000 perhaps. The number 60,000 in the middle of 1999. And then, you know what I'm saying? Like right above the year, you keep on going up. Look at the line with the two nodes at either end. And so that's what the data is suggesting. The data is saying that it's about 60,000. But in fact, if you go back to the data itself, where's that data? Going back to the data itself for Brazil, you have no idea actually where that number was. You have no idea whatsoever, no matter how much you might like to argue this thing. In this data, you have no idea where that or what was happening in June of 1999, in the middle of 1999. Even though this plot that you see right here suggests that there you do have some kind of in the middle here you do have some kind of, and of course it's rising. The 2 points of one point is higher than the other, but you don't know exactly where that rising was. And so if you look at this information, it's saying that in the middle of the year it was about 60. That isn't true. You don't know that. And so these plots, when you have a kind of a line plot, when you're plotting data that looks like this, by the way, or where you just have like 1999 and 2000, two nodes, and you use a line. When you use a line like this, it suggests that somehow the information between those points is also correct, but it's not correct. We don't know that. We only know where the nodes themselves are. In other words, we only know where the colored nodes are. And so we have all this kind of, hang on a second before I get to that, we have all this, we have these, you'll find that there's all these plots out there where you have, like, for instance, lines that are connecting two different points, and that's really not the reality of what the data is doing. Instead, what I would recommend is I would use a scatter plot for this rather than lines, because lines are misleading. They suggest that they're between those points where we are. So we're actually dealing with some bad organization here. We're trying to figure out. I mean, that was a badly organized plot, but we're really looking at tables which are badly organized. And so, how can we apply code to the data of these tables to kind of undo, undo some of these problems that we have here? How do we, like, for instance, how do we apply code to data when in the right when we're trying to make plots where we need to work with numbers or something? And also we ask ourselves, what happens when the data is badly stored? What if it's messy? What if there's no organization? Can you work with it? Well, we can work with it, but you have to do some information, you have to do some gathering, and you have to work with it in the ways that we're going to be talking about now. So our first thing that we're going to be talking about is something called gather. And gather is going to put together, it takes multiple columns here and it kind of ties them together, kind of like zips them together here. So I'll just read this. It says the gather function takes multiple columns to collapse into key value pairs, duplicating all other columns as necessary. So I think the best way of showing you how gather works is just to show you the tables here. So if you look at this plot here, you have a table in the upper left and another table in the lower right, and then you have the code that made this possible. Now, what this is doing is you can see that we have in the beginning table for the table 4A, which is badly organized, I have country, 1999, and 2000. Now, what I would like to do is to create a table where I I have all the year information in the same column. Let's just say that my analysis is such that I need all that information in the same column. It has to be that way. And also I want to have all the cases. My analysis is such that I don't care whether the cases came from 1999 or they came from 2000. I just want all cases together. And so you'd use something like gather, really to take all the information from 1999 and 2000, for first table there, and then to create a new table column called year, and then to place in that table column year 1999 and 2000, but not just to throw in the year, but actually to keep track of which numbers came from the year 1999 and 2000. So I wish I could point to this, but I just can't. So I'm looking at line 1 in the lower right-hand corner of Afghanistan, where we have year 1999 and 745. You can see that the 745 came from the first table, which is the upper left. That was the first 1999 reference. Second, the second piece of information from Afghanistan for the year 2000, we had 2666, I guess. 2,666, I guess, cases in this case. And you can see that information is 2000 Afghanistan. You have to go down to line 4 and you'll find it there. And so when I first saw these pieces of code here, I thought this was actually kind of confusing. How am I supposed to keep it together? But actually, what's happening is that you're recreating or you're reorganizing your data, and the organization does stick. It does remember how these things are. You don't have to worry about writing extra code to kind of like keep track of one column and record another. In fact, sometimes if you just write this one-liner here, create a new data set, and then you can just go through this columns of this data set and do what you like. So there's one gather. I've actually written into this in this green table. Hopefully you can see this. The green table is kind of in words what the code is doing. So you're taking the data from the columns 1999 and 2000 of table 4A. Then I place the year data into a new column called year. So year is the name of the column, or the actual that's what the column is in the table in the upper left. Then what I'm going to do is I'm going to take each of the information out of each of those years and organize them according to cases in a new column. I think that if it just looks confusing, please spend some time just staring at the two tables, and you'll see kind of like where everything's moving. When I first saw this, the headache on the horizon. So you're probably wondering, how does gather work? Well, this is straight out of your book. Where really what you're doing is you're just taking you're kind of pulling apart one of the tables and reorganizing the data, placing it into the next table. The next one we're going to talk about is I don't know if this is 4B. Is this the same? This is 4. That one, the other one was 4A. This is 4B. This is almost exactly the same thing. What we're doing is we're taking out the years 1999 and 2000, which you can find in the table in the upper left. And now I'm going to take out that information. I'm going to pour that information into a new column, a new table, which I'm going to be calling population. You'll notice that this code is exactly the same as the other code. Nothing is different. One thing that is different, though, is looking at this piece of code down here. Key is year. So this is going to be the column that, well, one of the columns I'm going to be creating here. But I'm going to say, hang on, maybe I should stand back for a second here. This over here, this 1999 and 2000, those are the actual names of the columns in the left-hand side table. Then I'm going to create this thing here called key, and that says follow the data from those two columns, 1999 and 2000. Remember which data came from 1999 and which data came from 2000, and then to organize that information in a new column, which I'm going to be calling population. And be sure to write, and then this key over here is the name of how you're organizing the data. That's its own. So really, these are the new columns that I'm creating, and this is the information where the columns in the old table where it's coming from. Here we are again, your green box, your friendly green box that tells you where the information is coming from and how it's getting there. Yes, sir. Yes, it is. So the question is this stored in a library? How can I get to these wonderful commands? This is in your TidyVerse. In TidyVerse. So I think that if you try running this without TidyVerse, it will not work. And I know, for instance, that this right here, that's the TidyVerse thing. That means and then. Take table 4B and then gather the information. So that's a TidyVerse thing. So I'm guessing that I'm thinking that the actual data itself, 4B, is also in TidyVerse. I think that this is also. In other words, if you run this, it's not working, use your library. Cool. Okay, so the next thing I want to talk about is something called spread. Spread is actually quite exciting. As exciting as these things can get. It kind of does the kind of the opposite as what we just did here, where notice that, for instance, in table 2, in fact, I have a spread here. So here we are. So when you see this command here, you have spread, and spread you can say look at the data for in this on this table 2 on the left hand side, where we have key and value. Now in key you have cases and population. In other words, this is a really annoying way of putting data because the value in the key column informs how to understand the value in the value column. And so it would be better not having a key column in data. So what this spread does is it kind of takes takes a column apart, and then it reallocates that data into a new column of a new table too. So here we have cases and population. You'll see that what this spread is doing is it says, okay, I see cases information and I see population information, and I see that there's a value for each of those in the value column. So what it does is it creates a new column called cases and a column called population, as we define, and then that's where the numbers come from. So what is the code that makes spread work? It's this. It's like almost it's like 5 or 6 inches long. It's tiny. If you wanted to do this, if you actually wanted to write code in Python to make this happen for a spreadsheet, it might be actually quite lengthy. I'm always impressed by the brevity of these pieces of code here. I mean, this is almost nothing. So what this has done now is you can see that we have the old column, country, year, type, and count. Now we have the new columns, the new table on the right, country, year, cases, and population. So it's gone through the year, pulled out the cases and population data for the year, and it's planted that information into new columns, cases, and population. Here's your little friendly green box that talks about what this code is actually doing. But this is the actual code that it is here. So here we have table 2, which is the data that we're getting here. Spread is the command. Table 2, that's this built-in data that we're working with. But you can use anything. You can always say that you have your own data in there. We say that key is equal to type, and what does that mean here? Well, that's the type column in the upper left-hand side table. So it says find this column called type, and look inside and see what you find. And it'll look inside that column and say, I see some categorical data. I see cases and population. Maybe that's not data. Maybe that's a marker of some kind. So I should pull out cases and population. And what else am I doing here? Oh, here we go. I'm looking at the information in the next table column called count. So I'm keeping track of that value count. And so what this is going to do now is it's going to remember which is cases and which is population, and it's going to create 2 new columns. I invite you to try these things, but in the interest of time today, I don't want to I don't want to spend too much time going through some of this code, but it's really there. I have all the output on the screen, which is why I'm not running this. But I do invite you though to try this out on this data or perhaps your own data, just to see how you like it. You might find that this is a real aid in how you're in working with data. I know that when I was working with data, when I was in grad school, I used some of these commands repeatedly because the data that I used to download on a daily basis from the protein websites had data that was just like table 2, where you have like there's this column type, cases, and population. And while I used to hate this data, I really I was really dependent on using this wrangling ability from R to make everything go easily for me. And so that's what I did. I made a macro with R, and it basically just created a new table from my old table. I had a macro written in R that would clean my data. Pretty cool. Cool is that? The next thing we have to talk about here is called separate. Separate in table 3. So now we ask ourselves, what do I do if my columns are somehow all kind of mangled together, and I'd like to separate them? I'd like to pull them apart and create 2 new columns. In other words, in this column, in the middle here, we see A1, B1, A2, B2. What if I want to pull out the B's and pull out the A's? How do I do that? Well, you can use the separate. And so what this is doing is actually separating the, it's actually pulling apart information. In this case, it's the demonstration is pulling apart what appears to be some kind of a fraction that exists in the rate column. Now, you're probably wondering, why would they create data like this? You may well ask, but I think though that in this particular data set, on some types of software, if this was data that you download and put into Excel, then maybe there would be an accompanying macro in Excel that would recognize everything in the rate column on the left-hand side and calculate that value for you. After all, a rate is going to be a floating point number, some number with decimal points. And so here you might find that you download the data and then you run a macro, and then it would go through and actually calculate all this math for you, and so that you can get the idea of you can see what the rate is. But the data actually comes to you with the numbers just showing like this, like the numbers plugged into an equation, so that you can see where the rates. So somebody decided that this would be a good idea to save space and to make things easy. But if you wanted I mean, and that might work for that particular um, application. But imagine, for instance, now that I knew that in my rate column on the left-hand side that the first number in bold was a cases number, and the second number was a population number. And I wanted to plot just the cases, or I want to plot just the population, or maybe plot them both, but I don't want them together. So how can I actually pull things apart? And that's where we use the separate command. And separate, what this thing will do is it says, okay, go to the rates column, and then I know this seems kind of like a strange command here, into, ridiculous. But into, it says go to the rate column here, and this thing into really says create two new columns. Create two new columns, and here we have this C cases, C population. Remember, that should actually be, that's your, if I were naming this, I'd call that V, that's a vector. It's an array. It's basically saying here's an array, here's the first column is called cases, the second column is called population, just an array. So don't be distracted by that C there. That's your array. That's how you define arrays. And then you're saying, okay, what am I doing with this stuff here? How do I populate the cases information and the population information? Well, go back to the rate column and pull everything out on the left-hand side and the right-hand side of this slash. And you can see that in the rate column, 745 slash 199, 19,987,71. That's your number here. But this allows you to actually pull both of those numbers apart, so that now I can create a new table where one column is cases and the other one is population, and the cases information is 745, and that's from the left-hand side of the rate. And the population for Afghanistan, another big number, which is the right-hand number. Maybe I'll run this just to see what it looks like, but I'll show you it's exactly the same. There's nothing new about that. But still, if I go here and I run this, you can see that table. Before I do that, let me just show you what table 3 looks like. The capital V, I can type in table, table 3. Oops, made a mistake there. Okay. Run this, and so you can see, maybe I can enlarge this. You can see, for instance, that this rate is, I mean, what is going on? Why would you have this slash in there? Well, again, because some data comes with macros, which allows the macros to calculate things for the user. So now what I'm going to do is I don't know why this is, but I have this right here, and so what this is doing now is it says now I have I have cases and population. I have a cases column, and I have a population. Actually, it's quite handy, and that's because into says create two columns. One is going to be called cases, one's called population, and the first thing that I pull out of rates on the left-hand side of this is going to be what I call cases, and the right-hand side of this thing that I find is called population, and that's where these numbers come from. Anyway, there's no magic in this. It's all actually just basic stuff. But if you, I mean, you might find though that when you have data that looks like this, that this could be a real wind at your sail. Help you get this thing done. Here's another one too, which is actually kind of interesting. Here, what we're doing is, if we don't have everything in quotes, here we have quotes saying separate by this character. But this is different in here, and this is what this is saying: separate everything not by character 2, but rather by the first two characters go into century, and the last two characters go into year. Let me show you what that looks like. Kind of an unusual thing, because we're used to seeing, I don't know why this is, whoops, there we go. This view is this. Okay, so now notice before, if I just show you what the table looks like. I have a table here where the year is 1999 and 2000. Now, what I'm doing, you can look above and you can look below. But before, I'm pulling out, for instance, here's the 1999. Here's the 2000, that's 2000, 1999. So what I'm doing is I'm breaking up my data. Now, why would I do this? Because maybe, for instance, I don't need to have this 19 and 20. Maybe, for instance, these last two numbers are good enough for my data. If I know that the year is this column here, maybe 99 and 2000 can be represented, or 1999 and the year 2000 can be represented by 99 and 00. And so maybe that's a new way of naming the information. So you can break apart your data here, or you can break apart your data by the year, which is actually kind of fun. All right, rock and roll, right? So this is kind of like this information about how you can break the year apart. I think discuss this. And then we have this unite. Here we are in the United States. How can we bring things together? Bring it back together. Let's unite things. Well, what do I do if I have two columns which are kind of separated and I want to bring them together like a zipper? What do I do? What do I do? Kind of like the opposite, I guess, for separate. Given a regular expression for a pattern of text, separate turns a single character column into multiple columns. But now I want to go from multiple columns back to single columns. What can I do? So this is your code for this. We're going to use something called unite. And in fact, I'll just show you the output here. What this is doing is it's going to make something called century year. And so I can create this column here called century year. I don't have this on this here, but what it does is it will put my year information together so that I have the 1999, the 19 and the 99 and the 20 and the 00 all kind of placed together. So if I go ahead and run this, you'll see that I can actually put together the table that I had. In fact, let me show you the table, original table 5. There you go. So here's the old table, which we just created by pulling apart the 19 and the 99 and the 20 and the 00. What this code does here, what this code does here is to put together those years and kind of zip them up. In other words, it combines columns. To extraordinary. It just combines columns. Otherwise, the other information is exactly the same. Same number. Okay, so yeah, if we do this here. So sorry, I didn't show you this part, but if you can see that these numbers were always the same. If I just run this thing here, it's in trouble, but it's work. But for instance, if you run 1999 and 2000, you can see, or if you run this code, you can see that you have a column called century year, which is now containing the year 1999 and 2000, and so you can kind of zip things together. Nothing else. Now, really, one thing I did want to spend some time talking about was missing values. We've spent some time talking about outliers and some other things, and they're just this anomalies you find in data. But what do you do, for instance, if there is data missing in your table? That's actually something pretty big, and that's in fact there are whole classes dedicated to that study. I mean, whole books dedicated to the notion of what do you do if you find that you have missing values. Well, first of all, you don't scream, you don't panic here, but you have to kind of get an idea about what kind of values they are that are missing. So there's two different kinds of missing values that I'll talk about. One is called explicitly, and the other one is called implicitly. And explicit values are values which they're explicit. In other words, they have been tagged as being present with an NA or not available. In other words, you have this information which is kind of you have a your table actually says NA. That means that when the data was being collected, somebody knew that the data wasn't collected for that thing, and so they had no idea what the data actually could have been. They just put NA, which meant the data was not available. That's explicit. That means you see it. You know that it's missing. But then you have another kind of data set, another kind of data that is called implicit, which means that you're working with data and you don't know that data is missing. This is the most annoying type of data to have, where, for instance, you're running this thing through and you find out after plots or after your analysis that there are giant gaps of information just missing. And you had no idea that it was missing because you didn't see that in the table, but you did when you plotted everything. So one thing that's actually kind of an interesting example of this is if I go ahead and run this table here, I'm going to use Tibble to create my own data table. You'll notice that, for instance, in the year 2005, I can see that this has been tagged as an A. That's an explicit hole in my data. That means it's an explicitly tagged information to say that it's missing. Something is explicitly tagged. That information is missing. So let's just go ahead and put that through and see what comes. I'll go back to my R, this here, and I'm going to put this there. And I'm not going to try and clean this up. I think it still works. It does work. It does look messy, but if I run this, if I look at my stocks, you can see, for instance, that the table, see that my table actually does have this explicit nature here. I can see that there's an NA. Goodness gracious, there's something missing in my data. It's right on this line here. But there's something else that I don't see, which is also missing. So let me just tell you something. This is stock market data. There are 4 quarters, I'm assuming, this data. It seems like it's in quarters. QTR for my header quarters. And so I have 4 quarters for the year 2015. However, for 2016, I have 3. So if you're not looking out for that, you would have missed it. You wouldn't have known. In fact, 2016, there's the quarter 2, quarter 3, and quarter 4, but I have no information for quarter 1. Oh my gosh, is that bad? It could be bad, especially if you're trying to decide what to do in 2017 with quarter 1 earnings. If you're trying to go back and reflect over what happened in 2016, the year before, in that same quarter, what do I do? Well, so you have some ways of you have some ways of working with that. What we're talking about now, though, is just kind of the systems of identifying that the data is missing. So in this case, for instance, the NA is actually already cleared up for you. R has already determined that is missing for you and put NA. But it did not determine that there was a quarter missing for the year 2016. And so that is where the implicit data problem comes from. That's this problem here. You just don't know that it's not there. You don't know what you don't know. So what we're going to do now is we're going to create a, we're going to use some of our commands that we just put together before to kind of organize our data in a way such that we can see that NAs are present. We actually see that information is missing. So if I go ahead and run this stocks, remember we have just, back over here, I've just created this stocks table. Oh, I've created this stocks table right here, and that was in the notes. I'm going to go over here. I'm going to paste this down here and run it. And you can see now that what it's done is it's looking through to see if you try to make 2 columns or 2 matching columns here, it tries to do that, and it says, okay, well, what I'm doing is I'm looking at the year, which is this information that's going to be coming from this array here. I'm looking at the year, and I'm basically trying to create 2 equally sized columns. The return is going to be this piece of information down here. Not the most. It's not the most neat way of looking at things here, but I'm looking at, where's my stocks? I guess this is it. So I'm looking at the year, which is this column over here. And what I'm doing is I'm going through and I'm looking at this column here called return. And I'm going to try and make 2 equally sized columns here based upon my year. Now, this only works, for instance, in this data set because we have 4 quarters. That means I'm expecting each year to have 4 rows. And so if that's the way that your data has been set up, then it works. Otherwise, it may not. But what I'm doing now is I'm just kind of taking apart my, oops, not this one. So what I'm doing is I'm using spread here to pull out my year, to pull out my return and create 2 different columns where each of the year is outlined. And this is how you're going to notice that your data is missing. So what I would recommend is in future, when you're running your data, if you suspect the data is missing, as data always is, then write a quick macro like this and look to see whether you have any NAs showing up. And if you find that you have NAs showing up, that means that you have If you didn't see them before and you see them now, that means you have an type of data missing. But in order to do that, like back here, you have to make sure that your columns do have some natural order to them. And what I mean by that is that, for instance, you have, in this case, you have orders, something that you can use to actually figure out how to break up your data here. So then once you've determined that you do have missing data, and I don't know that there's I mean, the jury is out on what to do about that. One thing that people would say is that if you have missing data, then the whole row has to be let go. It means you have to destroy the whole row. And that's exactly what this is doing. So here what we're doing is we're using spread, just as we did before, where we're taking the information and organizing it by column year, and we have another column called return. And if anything comes out where, for instance, with NAs, and we will see them. But what we're doing though is we have this other piece of code here. When we gather this column together, we're actually going to be looking at these columns and purging out any information which is missing. So this piece of information, or this piece of code right here, na.rm, NA means not available, dot remove equals true. So that means that if you find a case where there's an NA, then should we remove it? Either you put true or you can just leave it out and have it as false. It means it does not remove it, but that means that NAs are removed true. Is that true? So you can actually kind of like destroy rows of data for which the one of the values you're looking at has. So let's go ahead and try that and see what. If I go over here and I hit that, save it, I'll paste it in here. I run this. You can see now that, let's go back to the other data that I was working with before. My stocks data at 2015 had 188, okay. Next one is 159, okay. Next one is 035, okay, I've got that. And then I have an NA from this information from here. NA, that's explicit data here, so we can see that. But then over down in the bottom here, oops, no, let me save me again here. Oh, here we go. One. Sorry. What this is doing now is it's saying that I'm actually kind of destroying the information that's missing here. So the fourth quarter of 2015 is gone. The quarters are 1, 2, 3. And the first quarter of 2016 is also gone. And we didn't even know that that was there. And so let's go back through the steps and see how that actually happened. How did we get this to work? I find that whenever I'm working with some of the new R code, the first question I ask myself is, how does that work? If you spend some time actually going through the code and figuring out line by line, piece by piece, I guess as with any programming language, then it's not magic how it happened. You actually see how it happened. So what we're doing now is we're taking the data stocks. That's the data that has that missing information. And then what we do is we subject it to spread, year, and return, which means really to create two different columns, one called year, one called return, where the quarters are being used to kind of keep everything together. We can actually see the quarters more easily. And then what I'm going to do is I'm going to gather everything here. So that means now I'm going to take everything out my 2015 and 2016 years. And if in those 2 years, if I find, for instance, that there's something missing, then I'm going to drop it. In other words, we're really kind of creating the same table that we had before, but we're trimming things out. So here, take everything apart, see how everything falls. At this stage, you'll see where the NAs are. Now here, put everything back together and don't put back in place the NAs, because the missing information or the not available information is bad. So that's complicated, but it's one of the ways you'd use to trim out your data. If you run this, you know that the data that you're working with does not have any holes in it, no missing information. But one thing I will say is that you have lost information in doing this. So what do I mean by losing information? Well, imagine, for instance, that when I lose, I don't know, maybe I need to know, for instance, that there were 4 quarters in a particular year, even though I don't have, for instance, the year 16, or I don't have the first quarter for the year 2016, and I don't have the fourth quarter for the year 2015. Maybe I need to know that I had 4 quarters to begin with. And for instance, in this table here, you can't see that there are 4 quarters. And so that, I mean, of course, the word quarter suggests that there are 4 of them. But we don't know that maybe there's some other data that was somehow that was cut. We don't know that things were missing. So you don't know. This is a progression of the tables as they go through. We have the regular stocks data where we have missing information, implicit and explicit. Then we remove the NAs, and then we add the NAs to the data where the information is missing as we divide everything up. 2 columns aggregated by quarter. Then we put those 2 columns back together again into here and return. And if we come across an NA, which we added in the previous step for 3, then we remove that row. But again, you don't know in your data that perhaps there was a quarter that was that piece of information may have been removed. Yeah, well, it doesn't. That's not a very good. Maybe this isn't a very good example of. I can still see there's a quarter in table 3, but still, in some cases, though, you may have another row that you don't, or another column you don't see, and then by doing this, you're actually losing that information. That's there. This is another thing I wanted to show you. Let's put this in here. This is another table that I'm going to be creating where I think you'll see that you'll see that once I put this in, that something terrible is on the panel. And what this is that, sorry, pop that down. I'm going to create, here. So I'm creating a new table here, and if I look at my table, I have a table here. Now it says Derek Whitmore. It's a medical table. Derek Whitmore and Catherine Burke. They're taking treatments of some drug perhaps. It looks like Derek is taking a treatment of one of these things, and his response was a 7 scale, 7 out of 10. Catherine Burke, another name that I see, she took 1 treatment and her response was 4. Now I have 2 persons' names on rows 2 and 3, which are missing. How dangerous is that? I have no idea who those people were. That means there's 2 people in my hospital somewhere on one of my wards who have received some kind of treatment, and I'm unable to tell who they are. I don't know anything about what they are. So that means that if one of my staff comes along and gives them another dosage of this medicine, it might be they may have some kind of anaphylactic shock. It may be absolutely detrimental. And so when you have missing information, it's actually very, very dangerous in some cases, as you see right here. So let me go back to the slides for just a moment. And then there's a couple of things we could do. We can ask ourselves, like, well, how are we supposed to deal with this? Well, one thing that you should never do, and this is just, I'm just being facetious here, is that you can always fill in those missing entries with stuff that you make up. And I know that sounds like a terrible thing, but you'll be surprised how many times that happens in other kinds of data. People don't know. They just assume that the line previous, like for instance, in this case, we have Derek Whitmore, someone we don't know, and on line 2, and then on line 3, again someone we don't know is on line 3. If we don't know, then by this convention, we could just say that Derek Whitmore was line 1, 2, and 3, and we could use this statement or this command here called fill, which is really, really, really wrong. Let me just run this to show you what can happen. It's kind of I find it funny that people even look as they look for this as a kind of a solution. But you can see though that what it's done is it said, okay, take this line here, and if you have any gaps, it must be that this and this are just copies of this. So Derek Whitmore is being filled in. Now that is just awful, and I think that all of us here, we all can see that. But we only see these things when they're brought to our attention. Many times, for instance, many data scientists out there might be working in a hospital, and they'll say that, for instance, oh, I see that this is the way I always work for this. I always just imagine that the data above is the data that's missing below, and so that's fine. But the thing is though that you can't always do that. You really do have to consider the data itself, and so that goes back to one of the first things that I was telling you when we first met in this class, and that is that when you have a piece of data, you really do have to spend some time to go through to make sure that you understand what the columns mean. What's going on in those columns? Like, what are they doing? And in this case here, once you realize that these are patient names, it should be perfectly obvious. Just fill in a patient name from above for all the missing names. That's not how that data. That's, I think, really all I wanted to say about. I think that in my slides here. That's the end of my slides for this. And so we're done now with week 7.